Hi, I'm Derek, and I'll be showing how to find the derivative of an inverse function with the general proof. So first, I'll go over what the definition of an inverse function is, and then I'll show the formula for finding the derivative of an inverse function, and then also explain the general proof for it. And then I'll work through some sample problems and explain some common mistakes. So, what is an inverse function? Well, an inverse function is just a reversal of the original function. In simpler words, that just means that you swap the x and y values. For example, if the original function is y equals 3x, then the inverse of that would be, so you'd swap the x and y values, and you'd get x equals 3y. And then solving for y, you get y equals 1/3 x. Now, in proper notation, you'd write the original function as f of x equals 3x, then you'd write the inverse as f inverse of x is equal to 1/3 x. And an important theorem regarding inverse functions is that f of f inverse of x is equal to x. Now I'll be talking about the formula and the proof for finding the derivative of an inverse function. So if we let g of x be equal to f inverse of x, then there's a formula stating that g prime of x is equal to 1 over f prime of f inverse of x. So how do we get to this formula? Well, if we let the original function be y equals f inverse of x, then you can take the function of both sides and you'd end up with f of y equals f of f inverse of x. And remember, there was a theorem that showed that f of f inverse of x is equal to x. So you end up with f of y equals x. Then you can take the implicit differentiation of both sides of f of y equals x, and using the chain rule, the derivative of f of y is equal to f prime of y times y prime, and the derivative of x is just equal to 1. So if you isolate y prime, you get 1 over f prime of y. And using substitution, since you know y is just equal to f inverse of x, then using substitution, you end up with y prime equals 1 over f prime of f inverse of x, which is exactly what this formula states up here. So now I'll be working through the first sample problem. The problem states, the table above gives values of the differentiable functions f and g and f prime, the derivative of f, at selected values of x. If g of x is equal to f inverse of x, then what is the value of g prime of 4? So for this problem, you want to start off by writing the formula for finding the derivative of an inverse function. So g prime of x is equal to 1 over f prime of f inverse of x. And you need this for the next step. So next, you'll write g prime of x is equal to 1 over f prime of g of x, since the problem states that f inverse of x is equal to g of x. The reason you want to do this is because there isn't a function f inverse of x on the table, so you won't have anything to refer to anyway, so you need to substitute g of x in. So next, since the question's asking to find g prime of 4, then you want to substitute in 4 into x. So g prime of 4 is equal to 1 over f prime of g of 4. And from the table, we see that g of 4 is equal to negative 2. So that becomes 1 over f prime of negative 2. And then next, you just solve 1 over f prime of negative 2. So f prime of negative 2 is 4. So 1 over 4 would be your answer. So this would be the answer, D, 1/4. A common mistake for this question is people will evaluate f prime of 4 instead of f prime of g of 4, just because there's quite a lot of composite functions involved when solving this question. So you might get confused between f prime of 4 and f prime of g of 4. So make sure you solve g of 4 first before solving f prime of g of 4. And now I'll work through the last sample problem. The question states that f of x is equal to x cubed plus x and g of x is equal to f inverse of x. Find g prime of 2. So how do you solve this question? Well, the first thing you need to remember is the formula for finding the derivative of an inverse function. Next, you set the c in g prime of c equal to f of x. So in this case, the value of c is 2, so you set 2 equal to x cubed plus x. Then, through guess and check, you get x is equal to 1, which means that f of 1 is equal to 2. And if f of 1 is equal to 2, that means that f inverse of 2 is equal to 1, because remember, for inverse functions, you swap the x and y values. Next, you use the formula and then plug in 2 for x. So you get g prime of 2 is equal to 1 over f prime of f inverse of 2. And as we solved here, f inverse of 2 is equal to 1. So you end up with 1 over f prime of 1. And to solve for f prime of 1, you have to first figure out the derivative of f of x. So f prime of x is equal to 3x squared plus 1. And then plugging in 1 into that, you get 3 times 1 squared plus 1 is equal to 4. So f prime of 1 is equal to 4, and 1 over f prime of 1 is 1 over 4, which is the answer to this question. A common mistake in this question is that people often get confused between steps 2 and 3, where you have to use the definition of an inverse function, and people may just forget to swap the x and y values and just do f inverse of 1 instead of f inverse of 2. And then if you do that, then obviously you'll get the wrong derivative, and then which will obviously lead to the wrong answer. So you have to be careful here and make sure you're evaluating the right inverse function. So that is all for now. Hopefully through this video, you better understood how to find the derivative of an inverse function as well as solve problems related to it. Thank you for watching.